Hello everyone. Today we are going to discuss about the case study on application of Laplace transformation using design thinking approach.
So I am Pratiksha from first year food technology. So we are here to discuss about the topic applications of Laplace transforms on the basis of design thinking. So the empathy of this statement is understanding student struggles with complex differential equations, identify difficulty in solving time domain problems, recognize need for faster calculation methods, observing challenges in circuits and other self-analysis, focus on need for accurate and simple tools, difficulty in handling initial conditions, real-world problems seem complicated to model, lack of clarity in step-by-step problem solving, struggle to check and verify answers.
I'm Raisi from Food Technology. I'm going to talk about the define of the statement. In many engineering problems, mathematical equations are very complex and difficult to solve. These equations often involve challenges with respect to time, making calculations lengthy and confusing. There is no need to convert differential equation into simpler form so that it becomes easier to handle. Laplace transformers changes them into algebraic forms, so it is easy to solve it. Engineers require easy analysis of systems such as electrical circuits, machines, and mechanical devices. Laplace transformers helps us to study the machines with systems quickly. It also aims to reduce the time of the calculation and speed. Instead of solving long step-by-step process, Laplace transformers helps us to solve it much more quickly. And also, another important advantage of this, it handles the conditions very initial conditions very accurately. So we get results more accurately than other things.
I'm Pooja from first year food technology. I'm here to ideate the topic. Think of different mathematical solution methods. Consider graphical and numerical approaches. Use graphical methods to visualize and better understand the solution. Apply numerical methods to get approximate solution when needed. Explore transformation techniques to simplify problems. Select Laplace transform as best solution to convert it into easy algebraic forms.
I am Smriti from first year food technology. Today I prototype this statement, applications of Laplace transform. First of all, accept a differential equation as including initial conditions if provided. Next, apply the Laplace transform to convert the equation from time domain to frequency domain. Next, replace derivative with the algebraic expression using a variable. Next of all, convert the transformed equation into a simpler algebraic form. Use initial conditions during the solving process if required. Apply the inverse Laplace transform to convert the solution back to time domain. Last, simplify and present the final solutions.
Kripa Shetty, first year food technology student. I'm going to share the testing part of the statement. Testing is an important step to make a solution working properly. First, we check if these results are correct. Then we compare it with the traditional methods. We also ensure it solves problem faster. Next, we test in real-life situations. Finally, we confirm that it is accurate and reliable.
See a real-life example based on Laplace transform. In RLC circuit, when a switch is turned on, current voltage change with time. Using Laplace transform, the circuit differential equations are converted into algebraic equations. This makes it easy to calculate current, voltage, and independence in S domain. It also helps in analyzing both transient and steady-state behavior, widely used in designing filters, amplifiers, and power systems.
The other real-life application of Laplace transform is control systems. In systems like motor speed control or temperature control, we need to study system behavior over time. Laplace transform helps convert system equations into transfer functions. Engineers can analyze stability, accuracy, and system response easily. It is used to design controllers, helps in predicting how the system reacts to input and disturbances.
Greetings, I'm Ritvik. I am from first year food technology. I will conclude on the topic. Laplace transform is a powerful method that converts complex differential equations into simple algebraic forms, making problem solving easier. It reduces time, effort by improving the accuracy, especially in solving time domain problems. It is widely applied in engineering fields such as electrical circuits, control system, and signal processing, and so on. Using the design thinking approach, that is empathize, define, ideate, prototype and test, helps in better understanding and practical application of the concept. Overall, Laplace transform provides an efficient, systematic and relevant way to handle the real-world engineering problems. Thank you. Let's see another real-life example for Laplace transforms. The signal processing. Signals such as audio communication signals are often complex in the time domain. Laplace transforms converts them into frequency domains for the easier analysis and for easier calculations. Helps in filtering unwanted noises from the signals. Used in designing communication systems and signal transmissions. Signal processing plays a key role in image processing, speech processing, and data transmission.